second video on simultaneous equations. In this video we're going to look at some slightly harder problems. In this example here you'll notice that we don't have the same number in front of the x, we have a 6 and a 2. But that's also the same for the y, we have a 4 and a 5. These are different, so we can't use our usual approach of either adding or subtracting the equations. We can, however, get it to that point by scaling one or both of these equations. The thing to look for is a link between these numbers here, 2 and 6, or 4 and 5. Now I notice that 6 is actually in the 2 times table, so if I multiply 2 by 3, I would actually get 6. I would get these numbers the same and I could carry on like normal. So in order to do that, I'm going to take the second equation and I'm going to multiply it by 3. So what I do is I write the first equation out the same as it is, 6x plus 4y equals 26. And then I multiply the entire second equation by 3. So 2x times 3, that's 6x. 5y times 3, that's 15y. And then finally, 5 times 3 is 15. And there's a very common mistake here. A lot of people forget to multiply this n number here, 5, by 3 to get 15. Some people just put a 5 on the end. So what we've done is we've turned this equation into one that we can actually solve because the 6 is the same for both the x's. So we carry on as normal. They're both positive, so we subtract. 6x, take away 6x is 0x, so that's gone. 4y, take away 15y is negative 9y. And then 26, take away 15 is 9. So we end up with negative 9y equals 9, in which case y is negative 1. We'll then take that y and substitute it back into one of the equations. I'll use the first one. So we've got 6x plus 4y, but we know now that y is actually equal to negative 1. And this has got to equal 26. And we end up with an equation that we can solve. So 6x, 4 times negative 1 is negative 4, equals 26. And then 6x equals 26. You add 4 to both sides, so the 4 on the left is gone, and we get a 4 on the right. And then 6x must equal 26 plus 4 is 30. And then x must equal 30 divided by 6, which is 5. So the complete solution to this question is y is negative 1 and x equals 5. Let's have a look at a second example. Now in this one, we don't have that nice link that we had previously because we have a 5, not a 6, and 5 isn't in the 2 times table. So we go and check the same for the y's, and again we have the same problem, 3 isn't in the 2 times table. So what we actually have to do in this one is scale both equations to get one of these to be the same. Now you could use the x, but I'm going to use the y. So what I'm going to do is multiply this first equation here by 2 and double the whole equation. So if I double 5x, I get 10x. And if I double 3y, I get plus 6y. And if I double 44, I get 88. Now in order to make the y's the same, I need to make this a 6 as well. So I need to times this whole equation by 3, because then I'll get 6y. So 3 lots of 2x is 6x. 3 lots of negative 2y is negative 6y. And then 3 lots of 24 is 72. So I can carry on with the equation just like in the last video now, because both of the y's have a 6. They happen to have different signs, and if they're different signs then I add the equations. So if I add these, 10x add 6x is 16x. 6y add negative 6y, well that's 0. And then 88 add 72 is 160. And if 16x is 160, then x must be 160 divided by 16, which is 10. So I take my x equals 10 and I'll put it into the first equation, 5 lots of 10 plus 3y equals 44. And then 5 lots of 10, well that's 50, plus 3y equals 44. And then I solve this like I would any equation. 3y equals 44, subtract 50 from both sides, and then 3y equals, well, 44 subtract 50 is negative 6, so y must equal negative 6 divided by 3, which is negative 2. So the solution to this one is x equals 10, y equals negative 2. Okay, here are 4 questions for you to have a go at. If you press pause, have a go at those, and then press play when you're ready for me to take you through the answers. Okay, here are the answers then. So for the first question, I notice a nice link between the 2x and the 4x, so I'm going to keep the first equation the same, 4x plus 2y equals 24, but I'm going to double the second equation. I double 2x, I get 4x, I double 3y, I get 6y, and I double 20, I get 40. So I can get rid of these 4x's by subtracting. So 4x take away 4x is 0, 2y take away 6y is negative 4y, and then 24 take away 40 is negative 16, in which case y must equal 4. Not negative 4, note, because you've got a negative divided by a negative, negative 16 divided by a negative 4, that gives you a positive 4 as your answer. So you take that and put it back into one of these. I'm going for the first one, so 4x plus 2y, but I now know that y is 4, equals 24, and then 4x plus 8 equals 24. So 4x is 24, subtract 8 from both sides, in which case 4x equals 16, and x also equals 4. Okay, for this next equation, I notice that the link is with the y's. I have a plus 2y and a negative 8y, and if I times 2 by 4 I get 8, so I can multiply the whole first equation by 4. So I have 24x plus 8y, and 4 26's are 104. So I multiplied this whole equation by 4. The second equation, though, I will keep the same, so that I have a plus 8y and a negative 8y. And since those signs with the 8y's are different, I will add the equations. 24x plus 5x is 29x, 8y plus negative 8y is 0, and 104 plus 112 is 116. So if 29x equals 116, I need to do 116 divided by 29, which comes out as 4. So x is 4. I take x equals 4 and substitute it into one of the equations. I will go for the first one. So I've got 6x, but I know x is 4, plus 2y equals 26. Well, 6 4s is 24, plus 2y equals 26. I then subtract 24 from both sides, 26 subtract 24, and then I end up with 2y equals 2, in which case y must have equaled 1. Okay, now on this next question, unfortunately, there isn't a nice link, so we're going to have to multiply both equations. I'll multiply this first equation by 4 and the second equation by 5 to get both of the x's as 20. So let's multiply by 4 first. 20x minus 8y equals 84. And then multiply by 5 on the next one. 20x again, as we expected. Subtract 15y. And then 5 14s is 70. So we now have our x's the same. And they're both positive, so that's the same sign, in which case we have to subtract. So 20x take away 20x is 0. Now you have to be careful on the next bit. In negative 8y, subtract negative 15y. If you subtract a negative number, that's just like adding it, so it's actually negative 8, add 15, which will come out as positive 7y. And then 84 take 70 is 14. And if 7y is 14, then y must be 2. And then we take 2 and substitute it back into one of these. I'll go for the second equation. So we have 4x, subtract 3y, but I know that y is 2 now, equals 14. In which case 4x, subtract 6, equals 14. So 4x is 14 plus 6 to both sides. And then 4x equals 20. In which case x must be 20 divided by 4, which is 5. Okay, so let's go on to the last question. And in this one again, I'm going to have to multiply both equations. I'm going to multiply the first equation by 2 to get 14x, and the second equation by 7 to get 14x again. So let's multiply the first one by 2. 14x plus 6y, and 2 times 18 is 36, and the second one by 7. So 14x plus 35y equals 7. And now the x's are the same, and they're both positive, so I subtract. 14 take away 14 is 0. 6 take away 35 is negative 29. And then 36 take away 7 is 29. so y must equal negative 1. And then we substitute that back in. I will use the second equation again, 2x plus 5y, but I know y is negative 1, equals 1, in which case 2x subtract 5 equals 1, and then 2x equals 1 plus 5, 2x equals 6, in which case x equals 3. And that's the end of your video on simultaneous equations part 2.